Hi, this is going to be a series of videos about how to create the most effective generic annotations or symbols in a design project. The first step is to create a generic annotation or symbol. So here I am in a family editor. This is a generic annotation family category. Usually when we create a symbol or annotation, we could use some existing pictures. This is a 1/4-inch wide Batman logo from Icons 8. What we're going to do is to trace the line from the outside and end up with a lines and text symbol. The problem, however, is that when we're trying to create a symbol like this, from something like here, if we're going to trace the line, you'll notice that it is going to say the element is too small, and Revit just delete the lines that are too short. Basically, you cannot create the perfect outline of this part. So here is a workaround. Instead of using this a 1/4-inch wide picture, here I have a much larger picture. Obviously, in this larger sized picture, I will be able to trace the outline here, just doing this. And I will end up to have something like this thing. So now this is a much larger picture. What we can do is click scale and actually scale it down. And now this is somewhere similar to the picture that we just used. Actually, we could scale it down even more. So that this is the same size, but these lines, you see, they are retained. Now I have this smaller sized symbol. I can actually move it, copy it, or just do whatever I want with it. But again, if you try to create that line, it won't allow you. But if you scale it down, it actually creates a smaller lines that we can use in our symbol. So continue this process of tracing the lines outside a larger picture and scaling it down. We'll end up with something like this. Where I have all the lines, very short lines that you won't be able to create without scaling it down, and a filled region with solid black. See that I need to create separate filled regions for Batman's ear, just because these parts are also too short to create. If I go filled region and do that, it's not going to allow me. And the scaling down trick only works on lines. Even if I have a larger line in the filled region, editor and click scale to say something like that. Still gonna say lines is too short, and my only option is to delete all the lines. So for field regions, the scaling down trick doesn't work. All we have to do is make them one by one so that it will fill all the gaps in this area. Now that with all these set, we have our standard symbol to move on to fit other scenarios. Thank you. Now we have our basic generic annotation. We can load it into a project and see how that looks. So when I load it in, we start to notice that the blank space after that, behind that field region is actually transparent. So you will see whatever things that goes underneath it. Sometimes this is distracting. So a simple fix would be create a mask region. But again, when it comes to create masking regions, it's the same as the field region. You would end up with notice says element is too small on screen, and you cannot just generate that line. It's not going to be happening. A way to work around that is to have a separate generic annotation. Here I have this separate generic annotation family with only one big masking region as the background. So if I have something like this whole thing is a masking region, and I load this into our generic annotation and place it on top of it. Let's bring up the reference plane. And place the masking region on top of that original generic annotation. And when we try this and load into a project, we'll see that it's masking the whole background. And it is not masking anything that we have in our original generic annotation. So this one will be totally on top of everything and create a clean look generic annotation. This trick about creating a masking region underneath the original family is going to be useful when you have something like some kind of generic annotation, just like a bunch of lines. For example, if I have this as a symbol, as a generic annotation, and I want to mask the background, I will need to create 1, 2, 3, 4, 5, 6, 7, 8, 16 mask regions just to mask the whole background. But instead, we could load in a separate generic annotation as this whole mask region to mask all of this in the nested family. That way we saved the trouble of creating multiple masking regions, just because how this symbol or generic annotation looks like. There we go. Now we have this clean look symbols. Thank you. So now that we have the symbol with the masking, the next step will be to add a label to it. Sometimes the symbol itself is not enough, so we create a label as a identifier to what this particular symbol is used for. So for example, I'm going to create a ID, an instance parameter being a text. I'm gonna create it as a label here. And let's change the text size. So the thing with generic annotations is that the label itself has the keep readable parameter. It doesn't control whether this text will be kept readable when it's rotated. So ideally, we have this text and it says keep readable. And if I load into the project, and if I type in some parameter, and if I rotate it 180 degrees, it should be flipped back when the label is set to keep readable. Instead, for generic annotations, this parameter doesn't control that. Instead, is the family parameter, family properties. Here, the keep text readable, it can be found when you're in the editing space, or go to here, it says keep text readable. If I check that, it becomes checked. And notice that I have the keep readable for the label unchecked, and this part checked. If I load that in, it flips it back. So if I rotate that 180 degrees, the text is still straight up. This is not ideal when it's rotated 90 degrees because the text will become vertical. So there's one way to work around that. For example, if I'm going to create another label with the same parameter, and if I were to rotate this 90 degrees over here, I will essentially get two of the same parameter as a label, and this one will read straightforward when the label is rotated 90 degrees. For example, if I'm now to load this in, you get two labels, and whenever you're rotating, at least one of them will read like horizontal. So to take that to the next step, here I have two of the same labels, and I have them set assigned to a specific visibility parameters. There's the ID normal, and this one, the visibility parameter set to ID rotate. And when we go to the parameter label, we see that ID normal equals to not ID rotate. So in this way, if I load it in, I get this parameter. And if I were to rotate this symbol 90 degrees, I can go ahead and check the ID rotate. And it gives me the horizontal reading of the label all the time. When I rotate it again, I can uncheck the ID rotate, and the ID normal will become checked. And I have this horizontal text all the time. There you go. Now that we have our generic annotation with a text label and the ability to rotate the text label to accommodate different orientations, we can now add this into a 3D element. We're doing that by creating a new family, put that under generic model category, and we're loading this 2D annotation into the generic family. Put it in the center, like this. When we try to load this, now this falls under generic model category. This is a 3D model family, even though we don't have a 3D element in there yet. When we load this into the sample project, we will realize that something is not quite okay. Because the masking region masked everything out. Where is it? Here. So it turns out the nested generic annotation within a nested generic annotation within a generic model doesn't work all that well. Well, we can fix this by go to here, remove the masking, actually open the masking, and remove it from the generic annotation. Load this back to the family, override existing version, and then add the masking into the generic model family as well. Once we do it this way, if we load that into the project, if we load this into the project and override existing versions, now this is showing correct. See, the symbol is masking the concrete floor beneath it, and it is not covering up the field region that originally come with it. Once we've done this, we could talk about adding the, I don't need this, and we could add the 3D element to this family as well. So I'm using this, a Lego person. This is created by a Mr. Mullen. I'm using it as a demonstration purposes. So I can load this into the generic model family, and okay, let's place that here. So once this is done, if we load that into the project, we'll see now we have both the 3D element and the 2D symbol showing in the floor plan. And in 3D, there's our little figure. Oh, that's another one. Here's our little figure. So now, in order to have only a 2D or only the 3D showing on the floor plan, there is two approaches. I don't need this one more. One of them, if I go here and select this 3D element, go visibility settings, and uncheck the display in plan, so that the 3D element will not be visible in plan. Once I load that in, this will gone, and the 3D stays the same. But in the floor plan, you'll no longer see the 3D element. This is a common approach. Another one is that we go here, check the show up in plan, but then uncheck the show detail level cross. And then we select all the 2D element, the symbol and the masking, go to visibility settings, uncheck medium and fine. So it's only visible in cross. That way, when we load this in, so we have floor plan being a detail level medium, and this set plan, they're very close, being a detail level cross. So if I load that in and override, you see on a medium view, you see the 3D element, but then on the cross view, you see only the symbol. Essentially, I can add another one. It will be the same. And I can toggle between medium or cross to control whether showing a 2D symbol or a 3D element. So this way offers a little bit flexibility, and the other way, where 3D element is not visible in floor plan, will always you will only see the symbol all the time. On the other hand, we now don't have the ability to control the text label or the text orientations, because this is a different generic model family and it doesn't contain those parameters anymore. So we're going to add those parameters, or in another word, pass those parameters from the generic annotation to the generic model. If I click this generic annotation and the ID, associate family parameters, we're going to add parameters, ID, call it the same name, and also the ID rotate, call it the same name, ID rotate. Both instance parameters go OK. Now once we have associate what's in the generic annotation to this 3D family, if I load that in, you see I will now have the ability and have the parameter to control whether the text orientation will change or control the ID, because now I have the ability to do this within the generic model family. This way I have inherent what is in the 2D symbol to this now a 3D model family. There we go.